Hello everyone. We're going to continue with section 4.4 by discussing theoretical yield. So the learning objectives for this video explain the concepts of theoretical yield. We've already done limiting reactant in a previous video, and then derive the theoretical yield for a reaction under specified conditions, calculate percent yield for a reaction. So let's go ahead and move on to that section. Okay, so the percent yield concept is a way of keeping track of how successful, we might say, a chemical reaction is. So the percent yield is a comparison of what we call the theoretical yield and what we call the actual yield. So let's talk about these two things. The theoretical yield is basically what we would predict to happen based on stoichiometry. So this is something we've been doing throughout, basically through section 4.3 when we learned about stoichiometry. If we're given the amount of a reactant and asked to find the amount of a product, what we are doing is we're finding the theoretical yield. But then when we actually do the experiment and get a result, what we end up with is called the actual yield. So as we've done some experiments in the lab, I believe you'll all realize that it doesn't go perfectly. Sometimes you spill something on the floor, maybe something breaks, a lot can go wrong, and you don't always get exactly what you would expect. So one way of measuring that is with the percent yield. So the percent yield is basically taking the actual yield, what you got in the lab, divided by the theoretical yield, what you would have predicted to have gotten based on stoichiometry, and then multiplying that all by 100%. Okay, so that is basically the main idea of the remaining portion of this section. As you're doing this, one thing, I think the most important thing to remember here is that these have to be exactly the same units. And by exactly the same, that doesn't mean just grams. It means grams of the same thing. So if you have grams of, let's say you're making some water and your actual yield is in grams, then your theoretical yield has to also be in grams. You can't take grams of water divided by, say, grams of hydrogen. That would not be a percent yield. What this means is that oftentimes you will have to first calculate the theoretical yield before you can find the percent yield. You have to figure out how much you are predicting to create before you can figure out how close you got to the expected amount with your actual yield. So here we're looking at an example, and I just want to kind of walk through this a little bit. This equation isn't necessarily all that difficult. The difficult part is the part we've already done in module 4.3. So I want to make sure we're comfortable with that. Okay, so let's go ahead and read this example. So upon reaction of 1.27 grams of copper sulfate with excess zinc metal, 0.392 grams copper metal was obtained according to the equation that's shown here. So copper sulfate plus zinc to give copper plus zinc sulfate. And then the question is, what is the percent yield? So you're provided with two numbers within the question itself. These two numbers are not sufficient to answer the question of percent yield because they're measuring different things, right? So this is copper sulfate and this is copper. So what would need to be done is we would need to say, okay, given the amount of copper sulfate we have, how much copper would we predict? That would be our theoretical yield. So we do that first. So we're showing here, I'm not going to go through it in detail, but this is showing that step of finding the theoretical yield. So we're taking the reactant we start with, the amount of that, the 1.274 grams. We do a mass to mole conversion. We do a mole to mole conversion, so from here to here, and then we do a mole to mass conversion at that last step. So hopefully this looks very familiar to you as something that you were able to figure out in Module 4.3. If not, please pause right now, go back to Module 4.3 and figure that out before coming back here. Okay, so this should be something that you're comfortable with right now. We take the answer to that, and that is our theoretical yield, and we can then use the percent yield equation by taking the actual yield given in the question along with the theoretical yield that we just calculated. Okay, so we have to do this long calculation in order to get to the theoretical yield. And then we do the math and we get a number. So that's the numbers we have will often be somewhat less than 100%. There's a wide range there. Some reactions, if you get 30%, you're doing great. Some reactions you want more than 95% to feel like you have succeeded. It's possible to get a number bigger than 100% here. This might actually happen in the lab when we do this sort of calculation. And that happens when you have something where you are creating a product and it turns out that you don't just have that product, but you have some contamination along with it. Usually that contamination is just going to be water, but the presence of that will give you kind of a different result than you expect. So that is the percent yield concept. Please get some practice on the worksheets on Canvas, and that concludes section 4.4.